surface, one is constant and another one is stationary condition. Okay, there is a liquid between these two. If without applying any force on this plate, it will not move. Now you are applying some force on it, then definitely it will deform or it will flow. So due to that force, on a suppose I apply some force, so it will definitely deform. Suppose it deform delta theta 1. Again I push another force, then again it is theta 2, theta 3, theta 4. And similarly, when I applying some temperature, so with respect to time, due to that force, we determine the ratio of shear stress, because I am applying on that plate, and divided by rate of shear strength. Rate because with respect to time, and temperature obviously. If I am checking my dynamic viscosity at 40 degree, obviously it may be constant. For that we have another automatic unit. In that unit is calculating the dynamic viscosity or viscosity, and also calculating the density. We know there is a relation between kinematic viscosity and dynamic viscosity. So kinematic viscosity equal to dynamic viscosity divided by density. So our unit is displaying the kinematic viscosity by automatic unit. But here we will see the kinematic viscosity. I have a diesel sample, commercial diesel sample. As we know that the kinematic viscosity of the diesel at 40 degrees centigrade will be from 2 to 4.45 centistop. It should not be less than 2 and it should not be more than 4.45 centistop, which is required for the commercial diesel. So I have a viscometer. This is known as Ostward viscometer. It is 3 limb and 2 limb. Two type of viscometer are there. I will show you the 2 limb viscometer, or this is also known as U-tube viscometer. This viscometer are those samples which are heavy in nature or which are not transparent. And this is also a reverse flow, and you can only take one reading once, because once you are putting the sample over here, you have closed this one so that it should not go itself. First you close this one and fill the sample from this to this, and kept inside the temperature, at what temperature you need the kinematic viscosity. And while you are taking the sample in viscometer, keep it inside at least for 20 to 25 minutes, so that your sample should come in equilibrium condition. So once it has come into the equilibrium condition, you take it out the stopper which you have kept there, and now you will have checked the timing from this mark to this mark, flow timing of the liquid from this point to this point.
Okay.
So again question is having why this point has been given. It is for that when your liquid is reaching here, it is indicating that be careful. You just open your timer and be ready for that. So once your liquid is reaching here, and you switch on your timer and note down the timing, to flow timing from this point to this point. What is the flow timing? That should be in seconds, and multiply by the constant of the viscometer. Because kinematic viscosity is equal to time into constant of the viscometer which you are using for the kinematic viscosity. That will he will find the result in centistop or mm square per second, because 1 centistop equal to 1 mm square per second. So condition, and you can take the 1, 2, 3, 4 readings in one sample. So here minimum flow timing, it should not be less than 200 seconds while you are doing the kinematic viscosity. Now condition is what will be the maximum time. You can take maximum time, whether it is 4 hours, 5 hours, that is there. But if you have a 20 samples, that you will have to finish in one day. And as I told you, you can take the time, whether 5 hours and 8 hours. Can you finish all that 20 samples within one day? Not possible. So maximum time it doesn't matter, but you take that much time so that you can finish your. But important factor is the timing should not be less than 200 seconds, because there will be a one problem, that is kinetic energy effect. If your time is less than 200 seconds, then there a kinetic energy effect will be disturb your kinematic viscosity. If your denominator is higher, then obviously your numerator value will be lower, then your result will be lesser. So it will affect your kinematic viscosity. So minimum timing 200 seconds will be there. So how, in such a way we use the viscometer type, like number, there will be 1, 2, 3, 4 according to the capillary constant. So here we have taken the 3-limb viscometer, which is viscometer number is 3, and the constant may be, Prerna, what are the constants of the taken for the diesel, commercial diesel? Here you can see the first one, this is the constant of the viscometer, and this is viscometer number and code, number and code, and now this is the constant, capillary constant, where we will have to flow the liquid. So 0.009517, and this one is 0.009887. Now question is that how we come to know, if we have an unknown sample, so how we come to know which type of viscometer we can use? For that obviously we will have to apply the hit and trial method, because this is manual unit. But as we are doing the diesel samples last 18 years, so I know at which constant is required and which type of viscometer required. So I take the viscometer number is 3 and constant is this much. Now you can see the flow timing, which is more than 200 seconds. Yeah. It should be always more than 200 seconds.
Unknown sample, when in the unknown sample become difficult to select viscometer.
Sometimes, see, this is the experience. For example, you have bitumen sample, and definitely you will ask the kinematic viscosity at 135 degrees centigrade or 100 degrees centigrade. Now you can, first you just do the pour point of that particular sample. This is the best way to which viscometer is required for the kinematic viscosity.
Taking sample in your hand, you can assume. So
that is also experience. Exactly the same. This is the manual method. We don't have. Otherwise, you can use, first you take one viscometer, then if it take more time. Second thing, if timing is higher, so there will be a confusion. What confusion? See, the capillary is very. One confusion is that there is any choking inside the capillary, which is not visible, and time is higher. So there is again a confusion. You are thinking that okay, my time is maximum, my result will be good, but there is a choking inside the capillary. Yeah. That is why time has been more. So that is there also. That is I am telling you. So minimum time is 200 seconds, and maximum 1000 seconds is sufficient. Okay. So here, what we will do, here you can see that there is also a capillary where we will check the flow timing from this point. Marking is there. This bulb is there. On both sides there is a marking. First you suck the sample up to upper layer, and then take it out. When your liquid is reaching the top marked this viscometer, then switch on your timer, and when it reaching to at the lower level, and close it. Then you will check the timing and multiply by the constant. So she has already been done, but I will show you the another experimentally. But second, again, while you are taking the bath, because this is manual, if there is a variation of 0.1 degree, do you know you will find so many differences in kinematic viscosity. So it should be very careful. So my temperature right now is 40 degrees centigrade, when in this PID control is showing 39.72. So we will this is our calibrated thermometer. So now it is exactly 40 degrees centigrade. So now we will check the flow timing. How? See, when you are sucking the sample, you will have to close this lid. Otherwise, it will take air and there will be a bubble. There should not be any bubble inside the capillary. Now it is coming up.
Oh, bubble is coming.
No, you can see after completing that there should not be any bubble. I will make it to clear.
So by your hand you are pushing driving force.
Yeah.
It's driving. The value of driving force is a factor.
Let me finish it. I am just sucking by this bubbler. Is there any bubble now?
No.
I don't think so.
No.
So let me keep here, then timer will. Right. Now it started.
Where is it?
Keep it out. Now we will wait till to this point. Okay. Now second one.
It's so much more easier to do it with a rheometer. Rheometer more fancy. Rheometer. Easy control everything.
Now there is no bubble. Yeah, you can do it 3 times, 4 times, until you are not satisfied.
So we have started 2 timers, right?
2 timers. For now again we will repeat it again because we have 2 samples.
But what is the parameter here?
Oh, it's a,
This is in seconds, minutes, seconds, and microseconds, milliseconds.
Yeah. How about the A, B, C, D, E?
This is the number. You can take there is 8 samples altogether.
and 8 stopwatches.
Yeah, this is stopwatch. Prerna, how many readings you have taken? Give me a pen.
You mean you need to put in one?
Only once.
How to
You just see my finger. Just once you will have to press.
sample C?
9, 8, 7, 6, 5, 4, 3, 2.
Yes.
Okay, now
This is
9, 3,
355.97.
55.97.
Now this is again.
Which one is B?
235.
I think we are different one.
Yeah, the samples are different.
I think this one is.
Exactly. Why? When that girl are doing, at that point of time, temperature is 40.05. And right now the temperature is 40. Now you can see the difference. That is why I told you, there should not be a difference of 0.1. Though the difference is 0.05. Then you can see the difference.
No. I think the samples that we have written B here, and D here.
No, not at all. Not at all. Actually, she was doing, I saw the temperature, it was 40.05.
And now
So I
B?
told her, I just changed it. I changed it then, and then right now it's coming at 40 degrees centigrade.
Oh,
That is the main reason. The temperature is main issue.
Yeah, temperature. Yeah, temperature.
But it has been changed now.
The different temperature.
Which one is B? Which one is B? The left one or the right one?
This one is B.
This is B or A?
Inside.
Yes, exactly. This is the main reason. So let these bubbles should finish first. प्रेरणा आप करो ये दोनों.
ولا انا في المجموعه بتاعنا هل بيك انا هيك انا غادي انا دول
Which mechanical. Engineering. Machine. Umeelewa?
Mwalimu niko naye hapo asikuja na na jega nikishinda nikitaenda yulizi.
So
Bubble.
what happens when we put air?
Have a ball.
So look, when there is bubbles, then I'm just putting this one here and like this, and applying force. So there is no bubbles. Now the clear. You can see the capillary is clear. Yeah. Now I can perform the second time.
You took it again.
Msema katoka
Yes.
nani master dauni.
Master.
Hii hapa imeandikwa tube constant times. Umeona?
Sio pembeni.
For how many seconds you have to hold it like this?
That's the free now.
Until it does not raise up to the mark. You can see the mark.
Tube constant is to the front.
Do you see Thomas? Thomas.
Yeah.
Please.
Yeah, I
How Dr. Prima is doing.
the air
Look.
make come to get
Now
on.
I will left this one
Yani practical.
and see. And I can
The time only. But I put A okay, no?
not do this one.
Only B, yeah.
Yeah, from B.
And second one. The same, huh?
I just close this one and then this and like this.
Kutoka hapa mpaka iko vile hapa mpaka hapa. Silikuta mpaka kaingia kwa
How much timer earlier? Timing is